Hello and Assalamu alaikum everyone. So in this particular video, we will be discussing about how to solve a polynomial equation. Generally a third order polynomial equation, which is called a cubic equation, or sometimes you could also be asked to solve a fourth order polynomial equation, which is also called a quartic equation. To be able to understand the process of solving a cubic equation or a quartic equation, the very first thing you need to identify is the fact that you should know what is factor theorem, and you should also know the process of long division or synthetic division, which is something that I've already explained in the previous videos. To understand the process of solving a polynomial equation, we will do a bit of a reverse thinking here. Let's say you talk about an equation whose roots are known to you. Let's say the roots are alpha and beta and gamma. Let's say these are the values of x already. And then if these are the values of the roots of that particular equation, then what should be the factors of that particular equation? One factor should be x minus alpha, one factor should be x minus beta, and one factor should be x minus gamma. Now, if these are the factors, something that I really would want to highlight upon is the fact that if you will multiply these three factors, then of course your coefficient of the first term, which is x cubed, should be 1. Then you would have a term in x squared, then you would have a term in x as well, which is not very important for me at the moment. But what I really want you to see is the fact that the last constant term after doing all of this multiplication should be the product of these three numbers, which is alpha, beta, gamma. With the minus sign, well, that also is not very important, but what is important is that the last constant term has factors alpha, beta, and gamma. So from here, you can deduce that every time you're solving a cubic equation or quartic equation whose coefficient of the first term is 1, then the factors of the last constant term must represent the roots of that particular equation. Like for example, if I begin to solve this equation, which is x cubed minus 8x squared plus 5x plus 14 is equal to 0. So first thing that I would know is that the last constant term, which is 14 over here, the factors of this constant term must contain the roots of this particular polynomial. So I would be like that since 1 is definitely a factor of every term and 1 should be a factor of 14. Likewise, if I look at this number 14 over here, then 2 is also a factor of 14, 3 is not, 4 is not, 5 is not, 6 is not, but 7 is a factor of 14. And of course, 14 also itself is a factor of 14 with a plus and a minus sign. So I know that the three roots of this equation that I'm trying to solve have values either plus minus 1 or plus minus 2. So out of these 2, 4, 6, and 8 possibilities, 3 would be the factors of this particular, 3 would be the roots of this particular cubic polynomial. So my approach is basically going to be based on the trial solutions. So it's going to be more of a trial and error method where I substitute these values one by one, and then I see that in which case I get the answer as 0. So if I get the answer as 0, so that would mean that that particular number would be the factor of this particular cubic polynomial. So these are my trial solutions, and the first trial I'm going to do, I can suppose it, I mean, just for the part of my presentation, I can just write this down as fx, some function, which is x cubed minus 8x squared plus 5x plus 14. So as part of the process of solving this particular equation, you have to put in your trial solutions, which are plus minus 1 or plus minus 2, one by one, and you have to see what may give you an answer as 0. Like for instance, I put 1 over here. 1 cube is 1, minus 8 times 1 square is minus 8, plus 5 times 1 is 5, and plus 14. I really don't need to simplify this, but this is coming out with plus 20 and minus 8, which is plus 12. But more importantly, this is not coming out to be 0. What does that tell me? That tells me that 1 is not the root of this particular equation, because if that is a root of the equation, it should satisfy the equation and give me a 0. So then I would try out the other possibility. I'll substitute minus 1. Minus 1 cube is minus 1. Minus 8 times minus 1 square would simplify as minus 8. Plus 5 times minus 1 would simplify as minus 5. And then plus 14. Now, the thing is that if I would simplify this, this is becoming minus 14. And this is becoming plus 14. So this is becoming equal to 0. My trials will stop at this particular point. If supposedly I had put minus 1 and I was not still getting a 0, then what would I do? I would do plus 2. When I substitute plus 2, if I don't still get a 0, then I would substitute minus 2. I'll keep on doing that, but I'm pretty sure that out of these 8 possibilities, 3 will give me the correct answer. I mean, 3 would satisfy it to be 0. But I didn't have to go for that long, and I can sort of identify in this particular case that minus 1 is one of the roots of this equation. And if minus 1 is the root, then x should be equal to minus 1. This implies that x minus minus 1 is equal to 0 is one of the factors, or x plus 1 is one of the factors. So, you can sort of remember that if for any value f of a that you have supposed as a polynomial is coming out to be 0, then x minus a would be a factor. This is something that you can always sort of identify. So the first factor that you try and obtain is by substituting these values one by one and see what gets you a 0. And once you do identify what gets you a 0, then you get yourself the first factor. You continue on with this, but the thing is that it's not allowed according to your syllabus. You can actually get all your 3 factors this way, but this is not allowed in your examination. So you only find one factor by trial, and then the rest of the factors are obtained by first doing the process of long division or synthetic division. So if I know that this polynomial has one factor, which is x plus 1, and one solution as x is equal to minus 1, then to find out the other possible factor, I'm going to have to divide. So I'd say that, well, one factor is x plus 1. The other factor is a polynomial that I'm looking to find out, and that's equal to x cubed minus 8x squared plus 5x plus 14, which means the other factor, the polynomial that you're looking to find out, should be x cubed minus 8x squared plus 5x plus 14 divided by x plus 1. So that's what I'm saying here, that I am going to have to divide this polynomial with the first factor that I found out so that I get the other factor, which in this case is going to be coming out to be a quadratic one. And I can easily factorize quadratic factor furthermore by applying the middle term breaking formula, or in case if I can't further factorize it, then I can obviously apply a quadratic formula to get the roots from the quadratic equation. So quadratic is not going to be an issue for me. Well, I move on from here, and as we did discuss, now you have 2 possibilities. You can either get the other factor by long division, or you can get the other factor by synthetic division. Synthetic division has limitations. This has to be a linear factor, which it will always be because you've obtained it by trial solutions. But this linear factor has to have an integer value. So if it has a rational value, in this case you would always be getting an integer value, but later on I will be telling you a possibility where you might get a rational value or fractional value as well. So, but it's, as I said, in most of the cases, almost all of the cases, you will be getting first of all a linear factor, and you would have a value of x as being an integer. So you can always use, most of the times, this synthetic division method. So in synthetic division, I equate x plus 1 to 0, which I already have the value as -1. I write that down over here. I write down the coefficients of the polynomial in descending order. So I write down my coefficients of the polynomial, which are going to be 1, -8, +5, and +14. And after writing this down, I will copy this 1 below. -1 times 1 gives me -1. I add these up, I'm going to get -9. -1 times -9 gives me 9. I add these up, I'm going to get 14. -1 times 14 gives me -14, and I add these up, I'm going to get 0. I should be getting a 0 because I have found a factor, and since I know it's a factor, the remainder must come out to be 0. More importantly, I have gotten myself the other factor. These are the coefficients of the quadratic factor. So that will mean that I am going to say that one factor was found out as x plus 1, and the other factor is going to be x squared minus 9x plus 14. Actually, you have done the major work over here. You've gotten yourself a linear factor. The other factor is coming out to be quadratic. And as I did mention, that there are like certain possibilities. Either this is something that you would be able to factorize by middle term breaking. That would be very good. In few cases, if you're not able to factorize it furthermore by middle term breaking, then you can apply a quadratic formula onto that and then solve it. The formula is x equals minus b plus minus under root b square minus 4ac divided by 2a. So you can use this particular formula as well, but you don't really need to use that here. Why you don't really need to use that over here? Because this is a very, very simple case of breaking the middle term. So I would be like x squared, and then minus 9x can be written down as minus 2x minus 7x and then plus 14. So just sort of doing a recap that you should break the middle term into two terms so that their sum obviously is equal to this, but their product is equal to the product of the exterior terms. That's your rule for breaking the middle term. And once you've done that, then you will get yourself x plus 1 is the factor that you know right from the offset. And then you factorize this furthermore. I take x common, I'll be left with x minus 2. I'll take minus 7 common, I'll be left with again x minus 2. So I will do one more step over here. So one factor is x plus 1. If I take x minus 2 common from these two terms, then the other factor is going to be x minus 2, and the third factor is going to be x minus 7, and that's coming out to be 0. So once I have achieved this, I mean, either examiner could be asking me to find out the factors, or so I would stop here. But in case if examiner is asking me to solve this equation, then I now know all the three solutions of this cubic equation. One is -1, one of them is going to be +2, and one of them is going to be +7. And this is how you actually solve any cubic equation. Now, I mean, even if it's an equation like this, you just need to sort of multiply it by -1 and rewrite in that order, and then your last constant term would become -6, and your possible factors are going to be +-1, +-2, +-3, and +-6. So you do your trial solutions according to that. Now, let's just do one more example to sort of like revise the idea or the concept. Let's do this part 5 over here, which says x cubed minus 6x minus 4 equals 0. So I would do x cubed minus 6x minus 4 equals 0. The possible factors of the last constant term are +-1, +-2, and +-4. These are my trial solutions to see which gives me 0. I suppose fx, the original polynomial, as x cubed minus 6x minus 4. First of all, I put 1. I'm going to get 1 minus 6 minus 4. This is not coming out to be 0. It really doesn't matter for me that whether what value it's coming out to be. I just have to check it for it to be coming out to be 0 or not. Then I put minus 1. This will become minus 1 plus 6 and minus 4. And this is also not coming out to be 0. So I'm not going to go for this as well. Then I try out the other possibility, which is f of 2. That would be 2 cubed, which is 8, minus 6 times 2, which is minus 12, and then minus 4. And this is also not coming out to be 0. So this is also not going to be my one of the trial solutions. And then I will put minus 2. Minus 2 cubed becomes minus 8, minus 6 times minus 2 becomes plus 12, and then minus 4 as it is. And you can see over here that this is coming out to be 0. Once I've identified that this is coming out to be 0, then the value of x is minus 2, and x plus 2 is my one of the factors. To find out the other factor, as I said, I have two possibilities. I can do synthetic division or I can do long division. In these kind of situations, synthetic division gives you very quick answer. So this is going to be minus 2, coefficient of x cubed is 1, coefficient of x squared is 0, coefficient of x is minus 6, and constant term is minus 4. So I copy down 1 as it is. Minus 2 times 1 gives me minus 2, adding up gives me minus 2, minus 2 times minus 2 gives me 4, adding up gives me minus 2 again, minus 2 times minus 2 gives me 4, adding up gives me 0, and I am always anticipating 0 over here because I do know that this is going to be a factor, so remainder should come out to be 0. So my one factor is coming out to be x plus 2, and my another quadratic factor is coming out to be x squared minus 2x minus 2, that is equal to 0. Now it is one of those kind of situations where you can see that you can't break the middle term of this one. So you will try out the other possibility, which is, one answer is going to be minus 2, and the other two answers can be obtained by applying the quadratic formula. So this is going to be minus b, which is minus 2, plus minus under root b square, which is going to be minus 2 whole square, minus 4, a is 1, c is minus 2, whole divided by 2 times a, which is still going to be 1. So this is going to give me minus 2 plus minus under root 4 plus 8 divided by 2, and that becomes minus 2 plus minus. This is just like a simplification. You can do it on your own. This is 12 upon 2, and then I can take for outside the root sign, this is going to become plus minus 2 root 3 whole divided by 2. More importantly, if I cancel the 2 after taking 2 common from the numerator, my two other answers are coming out to be minus 1 plus minus root 3. So this cubic polynomial that I've just solved, one of its root is minus 2, and my two other roots are minus 1 plus root 3 and minus 1 minus root 3. Now, there is one more situation that I really want to talk about, and that is something that this is going to be explained through example 7, but you have to sort of identify that this is something that is very less likely to come in your exam, but it can come, and you should be prepared for this kind of situation. So basically what's going to happen over here is that if I have this particular equation, and the first thing that I'm going to do is that I will go for my trial solutions, which are going to be plus minus 1 and plus minus 3, which are the factors of the last constant term. So I have supposed fx is equal to 2x cubed plus x squared minus 6x minus 3. I put 1. and that gives me 2 plus 1 minus 6 minus 3, and that's not equal to 0. I put minus 1, that's going to give me minus 2 plus 1 plus 6 minus 3, that's also not coming out to be 0. Then I put 3, that's going to be 54 plus 9 minus 18 minus 3, this is also not equal to 0. I mean, you can just quickly check it through calculator. This is actually not coming out to be 0. And when I put minus 3, this will be minus 54 plus 9 plus 18 minus 3. And this is also not equal to 0. So I have used up all my possibilities, and after using up all my possibilities of the last factor, I am not getting an answer to be 0. Let me be very clear about it, that you expect this to come very, very less often. But yeah, I mean, for extreme situations, you have to prepare yourself for this kind of situation. Now, the thing is that all my possibilities are being exhausted. I've used all possibilities of the factors of the last term and nothing works here. Now, to be able to understand this thing, you again have to think in terms of the reverse process. Now, supposedly that you have a particular cubic equation whose roots are not giving you integer values. Let's say one equation has a factor, one factor of the equation is ax plus alpha, other factor is bx plus beta, and the other factor is cx plus gamma. So if you have something like this, and you do know that one root is alpha upon a, one root is with a minus sign, the other root is minus beta upon b, and the other root is minus gamma upon c. Now, if you will look at the simplification and not doing the entire simplification and just focusing on the first term and the last term, you will identify that the first term is going to be abcx cubed, and the last term is going to be alpha, beta, gamma, and which is more important for us. So that means that if your roots are as fractions, then your possible roots are the constant terms factors divided by the coefficient of the first term. So your possible solutions are going to be what? Your possible solutions are going to be factors of constant term divided by factors of cubic term. So I repeat myself, this is less likely to happen. But yeah, I mean, if you have tried all of these possibilities and they're not working, then you know that the other options you have is by dividing factors of this with the factors of this. So the other possibilities that I see over here are going to be plus minus the 1 upon 2 or plus minus 3 upon 2. So these are like the other possibilities that may probably give me the solution. So let's try this out. Let's see if that's possible or not. So I have to put first of all half. This is going to be 2 times 1 by 8 plus 1 by 4 minus 6 by 2 minus 3. This is 1 by 4 plus 1 by 4 minus 3 by 2. Sorry, this is minus 3 and minus 3. And this is not coming out to be 0. This clearly is not coming out to be 0. So then I try out f of minus half. And if I put minus half over here, this is going to come out to be minus 1 upon 4. The second term is going to be coming out to be plus 1 upon 4. Third term is going to be coming out to be plus 3. And last term is going to be coming out to be minus 3. And this is coming out to be 0. And this is where I will stop with my trial solutions. So guys, at this particular point, I actually do realize that the value of x is equal to negative half. And the factor is going to be 2x plus 1 after rearranging it. For this kind of situation, I have already told you it's not very advisable to go for synthetic division, because with coefficient of x, there are more complications attached with it. So what we're going to do over here is going to be a process of long division. and we are going to be dividing the polynomial 2x cubed plus x square minus 6x minus 3 by 2x plus 1. First term is going to be x square. That gives me 2x cubed, cancelling the first term out, plus x square. So I subtract it. Both terms actually sort of cancel out. I'd be left with minus 6x minus 3. I multiply it by minus 3, and that's my second term of the quotient, and that gives me minus 6x minus 3, and this completely cancels out as well, and which will mean that this is going to be a factor. It was already a factor, and I was anticipating to be a zero remainder. So for my working till this particular point, I've actually found out that one of the factors is 2x plus 1, and the other factor is x square minus 3. And this is basically equal to 0. Now, that tells me that one answer is going to be x equals negative half, and the other answer is going to be x equals plus minus under root 3. And these are going to be my three answers of this particular cubic equation. Now, one more example that I just wanted to discuss with you over here is going to be about this kind of situation where you have a quartic polynomial. You don't have to do anything new over here. You just have to do the same thing basically twice. Now, that basically means that when I'm solving this particular equation, I will find the first factor. I will find the first factor by trial and error. And once I found the first factor by trial and error, and then the remaining factor is going to be a cubic one, then I would have to repeat this process of trial and error. So that means I have to find two factors by trial and error, which will mean if I would look at the last constant term, so I'd have plus minus 1 as my trials, or plus minus 2 as my trials, or plus minus 4 as my trials. So if I suppose function to be x4 minus 5x cubed plus 4x square plus 6x minus 4, then first I'm going to put 1 over here. That's going to be 1 minus 5 plus 4 plus 6 minus 4. This is not coming out to be 0. Then I put minus 1 over here. That's going to be 1 plus 5 plus 4 minus 6 minus 4. So this is coming out to be 0, and that tells me that one of the factors is going to be x minus minus 1. That means x plus 1 is one of the factors. So I will not stop with my trials over here. I'm going to continue with my trials. I'm going to try 2 over here. That's going to give me 16 minus 40 plus 16 plus 12 and minus 4, and this is 32 plus 12, 44, and minus 44. This is also coming out to be 0. So x minus 2 is my other factor. So, I mean, the rest of the working is pretty much similar. I know one factor is x minus 2, and the other factor is x plus 1. I can multiply these to get myself a quadratic factor, x squared minus x plus 1. And then I will do long division to get the other quadratic factor. So first term of the quotient is going to be x squared, and that will give me x4 minus x cubed plus x squared. Subtracting these will give me minus 4x cubed plus 3x squared plus 6x minus 4. And my next term is going to be minus 4x. That gives me minus 4x cubed plus 4x squared minus 4x. I subtract these and I'll get myself minus x squared plus 2x minus 4. Okay, so once I have found out the two factors, x minus 2 and x plus 1, I can multiply these to get myself one of the quadratic factors. That's going to be x square minus x minus 2. And to get the other quadratic factor, I'm going to have to do the process of long division, which means x4 minus 5x cubed plus 4x square plus 6x minus 4 needs to be divided by x square minus x minus 2. I multiply it with x square, I'll get x4 minus x cubed minus 2x square. I subtract these, I'm going to get minus 4x cubed plus 6x square plus 6x minus 4. I'm going to multiply it with minus 4x, which will give me minus 4x cubed plus 4x square minus 8x. I subtract these again, I'm going to get 2x square plus 14x minus 4. And minus 2 times minus 4x will give me plus 8x. So when I subtract these, I'm going to be getting 2x square minus 2x minus 4. Multiplying it with plus 2 will give me 2x square minus 2x minus 4. And as anticipated, I will get the remainder as 0. So one of the factors is x square minus x minus 2, and the other factor is x square minus 4x plus 2. I already know the factors of x square minus x minus 2, which were originally x minus 2 and x plus 1. And then I can try and factorize the other term as well. But in this case, this term is not getting factorized, which will mean that if you had to find factors, you will stop here. But if you had to solve this equation, then one answer is going to be x is equal to 2, one answer is going to be x is equal to minus 1, and one answer can be obtained by applying the quadratic formula, which is x equals minus b plus minus under root b square minus 4ac divided by 2a. Now I believe if I find out it's b square minus 4ac, which will be 16 minus 4 times 1 times 2, well, this is coming out to be positive. But in case if this was coming out to be negative, then that means that you had unreal roots or you had complex solutions. And later on, there's going to be another chapter where we will link with this topic, and we will also deal with situations where we have to solve equations which have complex roots, and we will state our complex roots in those situations as well. So guys, this is pretty much it for solving cubic and quartic equations. I hope you liked the video. If you did, please subscribe to my channel and give this video a thumbs up. Thank you.